Okay, so this is the 11th part in the algebra series. So in this video we are going to discuss laws of indices and uh, logarithms. Right, so first we'll start with indices, laws of indices or exponents. This is also called exponents or powers. Right, so let's consider a and b to be real numbers and m and n to be integers. Right, so then this is the product rule for exponents. A to the m times a to the n is what? You just add the two exponents. So for example, minus 5 to the 3 times minus 5 to the 4 is going to be what? Minus 5 to the 3 plus 4, that is minus 5 to the 7. Similarly, we can write something for quotient of exponents. A to the m over a to the n, that is going to be the difference, m minus n. So for example, 3 to the 11 over 3 to the 6 is what? 3 to the 11 minus 6 or 3 to the 5. Okay, then a to the negative power can be written as a positive power using this 1 over a to the n, that is 1 over a whole thing raised to n. Here we have to take a to be non-zero because we can't divide by 0. Right. So for example, 4 to the minus 3 is same as 1 over 4 to the 3. So if you want to convert a negative power into a positive power, that's how you do it, 1 over that. Then this, when your base of the exponential, which is a, is not equal to 0, then a to the 0th power is always 1. So half to the 0 is 1, 100,000 to 0 is 1. Okay, so any non-zero number raised to 0th power is always 1. Then the distribution law, a m to the n, this is same as a m n, a to the m n. You can multiply the powers like that. So 6 to the 3 raised to 5 is same as 6 to the 15. Right, and then this one, if you have a product inside a times b raised to m, you can distribute the power to both terms. So you can write it as a to the m times b to the m. So for example, I have 2 times 9 raised to 5, so that is same as 2 to the 5 times 9 to the 5. You can write a similar law for a quotient inside. If it is a divided by b raised to m, that's going to be a to the m divided by b to the m, where b is non-zero. And for example, 3 over 8 raised to 9, that is same as 3 to the 9 raised to 8 to the 9. Right. Okay. So now let's do some examples using these laws of indices. So let's look at the first one, x raised to 3 times x to the 4. So here we are going to use the first law. We just need to do what? Add the powers. So the answer is what? X to the 7. Then the second example, we can use the second law. X to the 16 divided by x to the 10 is x to the 16 minus 10, that is x to the 6. Right. Then the third one, we can use first what? The 8th law combined with 7th law. It's a combination of these two laws. First you have to distribute the 5th power for this term and distribute the 3rd power 3 or this to all these terms. So let's do that. So you get a to the 10. This is a combination of these two, the 5th law, 2 times 5, b to the 5 times what you get, a to the 3 times 3 times 3. So that's going to be 9, B 2 times 3 6, C 3 times 3 C to the 9. Right. Now let's group the similar terms. A to the 10 times A to the 9, B to the 6 over B to the 5, and C to 1 over C to the 9. So then simplify. These two, just add the powers using the first law. For the B terms, use the second law. And we get what? A to the 19 times B over C to the 9. Right. Okay. So for the fourth one, I will just simplify the inside powers first. Then the outside power, we'll look at what happens. So first, x to the 3 divided by x to the minus 3 is what? X to the 3 minus minus 3, y to the minus 2 minus 2. Then that turns into what? X to the 6, write it here, x to the 6, y to the minus 4 to minus 2 power, that is same as x to the 6 over y to the 4 minus 2 power, so then x to the minus 12 y to the minus 8. Then if you want to write it in positive powers, you write 1 over x to the 12, 1 over y to the 8, then flip it and you get y over 8 divided by x to the, y to the 8 divided by x to the 12. Right. So using these 8 laws, you should be able to simplify expressions involving exponents. Right. Okay. Next topic we want to discuss is nth root of a real number. Okay. So let's see. Let a and b be real numbers and let n be greater than or equal to 2 be an integer. So n is an integer greater than or equal to 2 and a and b are just real numbers. Okay. Then if b to the n is equal to a, then b is the nth root of a. Okay. This is the expression. B to the nth power is equal to a means b is the nth root of a. So it is a square root when n equals 2 and it is a cube root when n equals 3. So for example, we know 2 squared is equal to 4. No? So then 2 is the square root of what? Square root of 4. That's what this statement says in general. So here b is 2, a is 4. So then 2 is the nth root. Here second root means square root of 4. Another example is, let's see, we know 3 cube is 27. That means what? 3 is the cube root of what? Cube root of 27. Right. Okay, now there are some special cases. There are two roots if a is positive and n is even. These roots are equal in magnitude and opposite in sign. If a, okay, so for example, right, we'll do example later. We'll go through the other case also. If a is a real number with at least one nth root, If A is a real number with at least one nth root, then the principal nth root of A is the number with the same sign as A. Okay, that's important. Principal nth root of A is the number with the same sign as A. That when raised to nth power equals to A. Okay. Principal nth root of A is denoted by this. This is the notation. A to the 1 over n power O, this root notation, nth root of A. Right. So now let's look at an example. Minus 2 to the 5 is equal to minus 32. Then minus 2 is the principal root of fifth principal root of what? Minus 32. They have the same sign. A has the same sign. Right. Now some root properties that we need to know. Right. A and B are real numbers and M and N are positive integers. Then this rule. Nth root of A to the M inside is same as nth root of A raised to M. So for example, this one, we have cube root of 8 squared inside, then you can write it as cube root of 8 whole thing raised to square, and cube root of 8 is what? 2, no? 2 squared is equal to 4. So you should know how to simplify these. And one more important thing, let's see. We need to know how to convert from roots to powers. So nth root of A is same as A to the 1 over n power. And from the first law, this one is what? Nth root of A whole thing raised to M, which is A to the 1 over n raised to M. So A to the M over n power. So we need to know that rule also. That is important when we are simplifying expressions involving roots. So A to the M inside the nth root is A to the M over n power. Right. Then the second law, nth root of A times nth root of B is same as nth root of AB. So here fourth root of 4 times fourth root of 64 can be written as inside 1 fourth root of 4 times 64, which is fourth root of 256, and we know that is equal to 4. And similar thing can be written for quotients. So nth root of A divided by nth root of B can be written as a single nth root. Inside you write A over B. So then the example, we have fifth root of 729 divided by fifth root of 3. That can be written as fifth root of 729 over 3 inside. So that is fifth root of 243, which is 3. Right. Then nth root inside another mth root. So that can be, you just multiply the roots, nth root. So you get mnth root of A. So here I have cube root of 4096 inside fourth root. Then that is equal to the 12th root of 4096, which is 2. Okay. And these two laws. Fifth one. Nth root of A to the n inside is equal to absolute value of A when n is even. When n is even. Okay. So for example, fourth root of minus 3 to the 4. So then that is absolute value of minus 3 is 3. Similarly, fourth root of 3 to the 4 is equal to 3. When n is odd, we don't need to consider absolute value. It's just going to cancel out the nth powers and you get a as the answer. Cube root of minus 2 to the 3 is just minus 2. Cube root of 2 to the 3 is just 2. Right. So those two, just remember two special cases. When one is n is even, other one n is odd. Right. Okay. Now let's use these laws to simplify these expressions. Right. This one we can use which law? Same root, no, fourth root. So we can use the third law. We can write them under single fourth root. X to the 7 over x cube. Now simplify. What do you get? Fourth root of x to the 4, right? X to the 7 divided by x to the 3 is what? X to the 7 minus 3. So then this one we'll write it as x. Right. The next one, we have sixth root. So then let me convert this into a power first. 64 a to the 6 b to the 7. This is 1 over 6 power. Now distribute 64 1 over 6 power, a to the 6 times 1 over 6, e to the 7. Now simplify again. 64 is what? 2 to the 6. This one 6 and 6 and 1 over 6 cancels to a. B to the 7 over 6. So then 6 and 1 over 6 cancel here. So 2a times b to the 7 over 6. Right. So you need to know how to simplify expressions involving roots. Right. Okay. Then one of the important topics, logarithms. Right. Logarithm of a positive real number a, important, with respect to base b. B is what? Positive real number not equal to 1. So remember, b is positive and not equal to 1. Your base has to be positive. Is the exponent by which b must be raised to a. So what that means is b raised to some value y equals a is same as if and only if log base b inside the log you have a equals y. So this form is called exponential form. Then this is called the log form. They are inverse of each other. Log function is the inverse of exponential function and exponential function is the inverse of log function. Right. So you need to know how to convert from exponential form to log form and from log form back to exponential form. So for example, this is the exponential form. 2 to the 5 equals 32. So how do we convert that into log form? It's easy to remember if you remember it like this. Numbers on the same line, these two. Those two are the ones that come on the log side. Here, can you see? So then log base what? Base 2, what's inside? 32 in the same order. First B, next A. So b is the base that comes first, then the number, then that is equal to that power. So here power is what? 5. So that's how you convert an exponential into the log form. Similarly, you need to know how to convert a log into exponential form. So now log form is given. Log base 39 is equal to 2. So how do you convert it? So this one you do what? Base raised to y here, b to y. So base raised to y. So your base raised to this number. So what is that? 3 squared, that is equal to what is inside of the log. So 3 squared equals 9. So that's how you convert from log form to exponential form. So you need to know how to go in both directions, exponential to log, then log to exponential, right? We'll do some more examples, right? So here log form is given, you want to convert it into exponential form. So how do you do it? Base raised to this number. So 5 squared is equal to what is inside? What is inside? 25. Right. Very simple. Right. Next one, log base 8 to equals 1/3. So 8 raised to this value, 8 raised to 1/3 is equal to what? Whatever number inside of log, which is 2. And important thing to remember, you can only put positive numbers inside of log. That is mentioned here. No? A is a positive real number. So the domain of the log function is positive real numbers. Right. Okay. So now we converted logs to exponential form. Now we'll do exercise where we go in the other direction. So these are given in exponential form. Now let's convert them into log form. So remember the trick. Numbers on the same level comes in the log side. So log base 1000 inside is equal to 3. Then next one, now what? Base 4, log base 4 0.125 is equal to minus 3 over 2. Right. So now we know how to convert from log to exponential or exponential to log. Right. Okay. So now let's try to evaluate log expressions without using a calculator. Right. So here I want to find log 327 value. So let's say that is equal to y. So we want to find y there. We want to find log 327 value. So let's equal it to y. So the objective is to find y. So the method is convert to exponential form. Then you can find the answer. So convert to exponential form. So then this is what? 3 to the y equals 27. Right. So that is equal 3 to the y equals to 3 cube. So then same base, no? So then we can drop the base and equal the exponent. So y equals 3. So that means what? Log 327 is equal to 3. So we just convert it into exponential form, then we can get the answer. Let's do the second one. Log 4 2 equal to y, again convert to exponential form, which is 4 to the y equals 2. I need to write it in same base. So this is 2 to the 1. So let me write 4 as 2 squared. 2 squared y equals 2 to the 1. Then 2 to the 2y equals 2 to the 1. That means what? 2y equals 1. So y equals half. So that means what? Log 4 base 4 2 is equal to half. Right. So method is convert to exponential form, and then the exponential equation write both sides with the same power. Then sorry, not same power, same base. Then you can equal the powers or the exponents to get the answer. Then let's do the last one. Let me do it here. Log 2 1 over 4. Let me equal it to y. Then 2 to the y is equal to 1 over 4. So 2 to the y is equal to what? 2 to the minus 2. Because 1 over 4 is what? 1 over 2 square. So that means y is equal to minus 2. Then the answer is what? Log base 2 1 over 4 is equal to minus 2. Right. Right. Then we need to know some properties of logarithms. The first property is log any base 1 is equal to 0. So we can quickly prove it if we want. Log b, we want to find log any base which is b. Log b1 is, let's equal it to y. So we want to find y. So we get what? B to the y equals 1. 1 can be written as what? B to the 0. So then y equals 0. So we have the proof of the statement. So remember, log any base, here we take it as b. So log b, base b1 is always 0. Then the second one is log base b inside also b. That is always going to be equal to 1. We can quickly prove it. Again, convert to exponential form. So b to the y equals b. B is same as what? B to the 1. So that means what? Y equals 1. Correct? Right. And similarly, you can prove the third one. Third one is what? Log b, and inside you have b to the x. So then what's that going to be? B to the y equals b to the x. So same base, no, drop the base, so you get y equals x. So log base b, b to the x is always going to be equal to x. Then we have an exponential one. So here you have base b raised to log bx is going to be always equal to x. The base and the log part cancels and you are only left with just x. Right. Okay, now after the properties we also need to know some laws. These three laws are very important. Okay, so b is a positive number not equal to 1, which is our base. A, b and c are real numbers with a and b being positive. C can be any real number. Okay, right. Then the first law is the product law. If you have a product inside of the log, then you can write it as a sum. Log ba plus log bb. Then the second law is, if you have a quotient, you can write it as a difference. Log b a over b can be written as log ba minus log bb. And the third law is, if you have an exponent inside, you can bring it outside. So if you have c exponent inside, that c, here our exponent is c, that you can bring it to the front and write as c times log ba. Right. Okay, so let's quickly go through the proof of these three. So let's say log ba is equal to x and log bb is equal to y. Wait, then this becomes what b to the x equals a, and log b, capital B equals y, that will become what, b to the y equals capital B. Then let's take this as 1, this as 2. Okay, let me multiply 1 and 2. Then what do you get? B to the x times b to the y equals ab, that is b to the x plus y equals ab. Now this exponential, let's convert to log form. So what do you get? Log base b ab equals x plus y. What is x? Log ba. What is y? Log bb. So that's the proof of the product law. Then similarly you can do what? The quotient law. So I have to do what? 1 equation 1 divided by 2, right? So then b over x divided by b over b to the y, b to the x divided by b to the y is equal to a over b. This is b to the x minus y, a over b. Then convert to log form. So log base b, a over b inside is equal to x minus y, and what is x? X is log ba minus log y is log b, capital B. So that's the second law. Right. Then let's look at the third one. So we want this, right? So we know from the first equation b to the x is equal to a. Then let's raise this to c power, b to the x to the c, a to the c. Right, now this becomes b to the xc, a to the c. Convert to log form, you get what? Log base b, a to the c equals what? Cx. And what is x? X is log base b a. So there's the proof of the third law. So these three laws you should memorize. So Remember, any product can be written as a sum. So you can go both ways. Any sum can be written as a product, and any quotient can be written as a difference, or any difference can be written as a quotient. And an exponent inside can be written outside, or any number that is outside can be moved inside into the exponent position, right? Okay, now let's do some more exercises. So solving logarithmic equations, right? Let's look at the first one. Right, this one we need to find x, so just convert to exponential form. That's the method. If it is just one log term, it's the method. So we get what? X to the half is equal to 16. We want to find x, no? So square both sides. So x equals 16 squared, or 256. Right. Second one is the same method. When it is one log term, just convert to exponential form. 3 to the x equals 81. 3 to the x equals 3 to the 4. That means x equals 4. Log 5 x equals 3. Then what? 5 cube equals x. So that means x equals what? 1, 2, 5. Right. Then let's look at fourth one. So now fourth one is little bit different because there's more than one log term. Plus log 2x minus 3. And here notice there's no base given, right? There's no base written. When it is, this is just a notation, okay? So we'll write that down. When they don't write any base, it's like this log. That means it's base 10. This log is same as equal to log base 10. This is called common log. There's another one you will encounter, ln. Ln means log base e. So log base e shorthand notation is ln. That is called natural log. Right. So in this question, we are dealing with base 10 logs. Okay. Log means just base 10. Right. So now, when there's more than one log term, you have to combine them. So into a single log term on both sides. So this side can combine to a single log term using your knowledge about log laws and properties. So I can write this as well. 2 log x. This is a sum. No, sum can be written as a product using the first product law. Log 3 into 2x minus 3. This is using this law. A sum can be written as a product. Then we can move this 2 inside also. On the left hand side, there's a 2 outside. No? How do we do that? Using the third law, exponent law. This c we can move into the exponential position, exponent position. So you get log x squared equals log 6x minus 9. So both sides have the same log term, no? Right? Same base 10 logs. So then you can drop the logs. and just equal the what's inside of these log terms. Then it becomes a quadratic. You just solve the quadratic. So x minus 3 all things squared. So x equals 3. So that's the answer. So when there's more than one log term, combine. Okay. Then we can use this uh, fact. Log base bx equals log base by is what? Just x equals y. You can just drop the logs. That's what we did here. Right. Now let's do the last one. Log 10. So here they have explicitly given it as log 10, which is just common log. X squared plus 9 minus 2 log 10 x equals 1. Right, one side has logs, other side has just a number. So because there's more than one log term, just combine into a single log. So to do that, any constant in front you have to move to the exponent position. Otherwise we can't use the product law or the quotient law. Okay, so first move any constants in front into the exponent position using the exponent law. So log 10 x squared plus 9 minus sign you can keep outside, just move the number 2. So log 10 x squared equals 1. Now we can use which law? A difference can be written as what? A quotient. So this can be written as log base 10 x squared plus 9 over x squared is equal to 1. So now this is like the first three problems we did. A log term equals some number. So then you convert this into what? Exponential form. So x squared plus 9 over x squared is equal to what? 10 to the 1. Now just cross multiply and get the answer. X squared plus 9 equals 10x squared over x squared equals 9x squared equals 9. So x squared equals 1. So x equals plus or minus 1. Are both answers correct? So remember, you can only put positive numbers inside a log term. So when I put plus 1, this becomes 10. It's fine. This is also positive. When I put minus 1, this term is fine. Minus 1 squared is 1. Then you get plus 10, fine. But here, what happens? I can't put minus, no. I can't put minus 1. X equals minus 1 fails because you can't put a negative number inside. So final answer is what? X equals 1, because minus 1 will fail the original equation. So when you get two answers, double check whether both answers are correct or only one answer can be used. Right. Okay, then the final topic in logarithms is change of base. Right. So there's two change of base formulas you should know. First one is log base ba is same as 1 over log base ab. You just repeat. And the other one is you can write log base ba using a different base, log base ca over log base cb. So the reason is, when you take calculators, they will only have log button and ln button. So only base 10 and base e. So then to calculate something like this, log 3 7. We have to convert this into one of the two bases we know. So I can do it like log 10 7 over log 10 3. Then I can use the calculator and find it. So that's one reason we have this change of base formula. Right, now let's do some problems using this. So log 5 6 is equal to a and log 5 11 is equal to b. Rewrite the expressions. Wait, wait, this question is incomplete, so just ignore that one. We'll move on to the next exercise. Right, let's look at exercise 5. Right, first we have to show this. Show that log 9 xy squared is equal to half log 3x plus log 3y. Right, so then we'll start with this side, left hand side. So here we have to show left hand side is equal to this. So product has been written as a sum, no? So that's what we need to do. We have a product inside, right? What's the product inside? X times y square. So then I can first write it as log 9x plus log 9 y square. Okay, now notice that this side is written in base 3, right? This side is written in base 3, but I have these two terms in base 9. So I have to use what? Change of base formula for each of these terms. So I have to use log base 3. So log base 3x over log base 3 9 plus log base 3y squared over log base 3 9. Then this we know, no? Log base 3 9 is what? Log 3 squared, that we know is equal to 2. So we can use that here. So log base 3x over 2 log 3y. Let me take this 2 outside using the exponent law. So 2 log 3y over 2. Now simplify. So what do you get? Half log 3x, 2 and 2 cancel, log 3y. So this is an application of the second form of the change of base formula. So base 9 we convert to base 3. We can write it in any base we like. So here it is base 3. Right. Okay, then using that we have to solve this simultaneous set of equations. So then I can convert the first equation into what? Half log 3x plus log 3y equals half. So that is the new first equation. So let me write that again here. Half log 3x plus log 3y equals half. That's the first equation. Then the second equation is what? Log 3x times log 3y equals minus 3. Right, so now solve simultaneously. So I can do what? From the first one, I will subject log 3y. Log 3y is equal to what? Half minus half log 3x. Let me mark it as 3. So then sub 3 into 2. So we get what? Log 3x half minus half log 3x equals minus 3. So let me just take log 3x as m. So then this turns into what? M half minus half m equals minus 3. So then half m minus half m squared equals minus 3. Then multiply by 2, m minus m squared minus 6. So m squared minus m minus 6 equals 0. So let's then, it's a quadratic, no? So factor this. So you get m minus 3 plus 2, right? Yes. So then we have what? M equals 3 or m equals minus 2. And m is what? Log 3x, right? So log 3x equals 3. So from this one we have what? Convert to exponential form to get the answer. X equals 3 cube or x equals 27. And from this one, what do we have? Log 3x equals minus 2. So x equals 3 to the minus 2 or x equals 1 over 9. So for each case, figure out the y values. When x equals 27, what's the y value? Log 3 y is equal to what? Half minus 3 over 2, right? Because we know log 327, log 327 is 3, so 3 over 2. So log 3 y equals minus 1. So y equals 3 to the minus 1 or 1/3. So one solution is x is 27. So we'll write it here. One solution is x 27, y 1/3. Other one is what? When x equals 1 over 9. When x equals 1 over 9, what is happening? Log 3y half, you have minus half minus 1, right? No, minus 2. Log 3 1 over 9, so then 3 to the minus 2 minus 2. So this becomes minus 1 plus 1, 3 over 2, right? 3 over 2 minus 1 plus 1 plus 1, yes, 3 over 2. So then y equals 3 to the 3 over 2 power. So then other answer is x equals 1 over 9, y equals 3 to the 3 over 2 power. So that's the final answer. You get two solutions for this set of simultaneous equations, right? Then we'll do one more exercise, right? Okay, so we want to find the value of this log expression, and we are given x, y and z are positive real numbers. Here look, 1 over log xy z, 1 over log yz xyz log zx xyz. So all three terms, the value inside is what? Xyz. But they have three different bases. But look, because the value inside is the same, we can use the first form of the log change of base formula to write all three terms using the same base. We'll use this one. So then I will write for the first term log xy can be written as what? 1 over 1 over log xy xy. You flip it using the rule. So then first term becomes what? Log xy xy. So similarly we can do the other two terms. Can you see? So then this expression becomes what? Log xy xy. Let me write the other terms also quickly. So this is 1. Then the second term is what? Log yz xyz. Use the change of base formula. So then you get this. So then what? Log xyz base inside yz. Then the third one, log zx log zx xyz. So again use the change of base. Then this just turns into log xyz zx. So then using 1, 2 and 3 we can rewrite the expression as what? 1 over log xyz plus 1 over 1 over log yz xyz plus 1 over log zx xyz is equal to what? Log xyz xy plus log xyz yz plus log xyz zx. Now you have to combine these three logs into a single term using the product rule, because they are in the same base. No, so now we can use the log rules. So I will first combine the first two. So you get what? Xy into yz. So xy squared z plus log xy zx. Now combine these two into a single log. So you get what? Log xy x squared y squared z squared inside. So now just simplify this a little bit. So this turns into log xyz. You can take the square power out. So like that. You can write it like that. Then use our exponent rule. 2 you can bring to the front. 2 log xyz inside also xyz. What is that? That is equal to 1. So answer is what? 2. So this is another application of change of base formula. Right. Okay. Okay. So that's all for logarithms and indices. In the next few lessons, we will learn how to do inequalities. Different types of inequalities. Okay. We'll start with linear inequalities, then move on to quotients, then to absolute value inequalities, right?